I guess we're live. Just checking here.
There is some echo coming in. There wasn't.
Hello, everyone. Just doing some tests. Just checking the audio now. I think we're good to go. So hello, everyone, and welcome to our weekly live stream on Twitch. So today, what we'll be discussing is best practices for real-time machine learning. I'll be doing the demo and live coding, but also I'll be checking the live chat. So feel free to drop any question you have in the chat box. I will try to multitask basically. And yeah, if you have any question, leave it below. I'm quite excited for this talk. Essentially, what we'll go through a couple of slides just to explain the concept for this talk. And if you have any question, feel free to drop your question in the chat box. And with that being said, let me just do this. Okay, hopefully you can see my screen now. So as I mentioned, what I will be doing today is discussing the best practices for real-time machine learning. And essentially what I would like to talk about is kind of like the secret sauce for real-time machine learning. So some of you might heard of machine learning before, or some of you might also heard about real-time stream processing. And essentially, real-time machine learning is a combination, basically. So if you really want to nail it down, what you'll be looking for is to combine between high-performance real-time processing and robust machine learning. So if you're coming, for example, from a data science background, you probably focus on your machine learning model and how you can optimize it. And if you're working on the DevOps side, you might be interested more about how you can deploy your application and how you can scale it. And the secret sauce for best practices for real-time machine learning is combination between these two elements. So I will be focusing today about specific case for machine learning in real time, and I will be looking at fraud detection. I think all of us use some kind of mechanism for either like online payments or card payments or mobile payments and so on. And fraud detection is quite an interesting topic in terms of real-time machine learning. So I'm getting some echoes here, so hopefully you're not getting the same echo. Okay. So yeah, what we're looking for is kind of like duplicating testing, and this essentially like trends in your account, and essentially all of us like have some kind of spikes and trends on our bank accounts, for example, and what you want from the machine learning model is to detect any fraud activities when it comes to replicating your transactions, basically. And this leads us to like pattern detection. So for example, all of us like have like the top-bottom approach. If we have like a 1 month time frame where, at the start of the month, we kind of like have our salary is paid in, and essentially the amount will start to decline. And essentially, this is kind of like pattern you might be considering to look at when it comes to fraud detection. Account scoring is what I want to discuss today about on live coding. So essentially, we give transactions and accounts a specific score. We're not interested how this score is calculated, because this is like comes from your bank account. Essentially, what we want is how we can use this score to detect fraud. Another area that we might focus on is also identity theft, where someone else is, pretending to be you, or even like we want to reduce the false positive. So false positive in fraud detections means like a valid transaction is declined. So most of fraud detections algorithms focus in the traditional machine learning on calculating specific score and writing machine learning model and collecting a specific input. And this refers to maybe like your transaction history. And then the algorithm will decide if there is a fraud on your transaction or not. Whereas what we do in Hazelcast is we have the ability to combine real-time data with data at rest, such as like, for example, your current transaction and your historic transaction, and we can use multiple algorithms. So I will show you what I mean in 1 second here in the live code session. But before I do the live code, I just want to highlight how we can actually build this application. So as you can see here, what we have is a kind of like input. So we have transactions from one side, and we have date and time for these type of transactions. And also we can have also number of transactions and score. So the score here by itself is not important, simply because this can be, referring to either like your back or credit score if you're in the UK or somewhere else. So this value is not important. So what we are trying to do is check these transactions. We give it a score and we import it into Hazelcast. Once we import it to Hazelcast, we actually create two maps. So the first map will be a trend based on these transactions. And then we can also create a prediction map. And the output, as you can see here, is same transactions, but it will have the output either 0, which refers to no fraud, or 1, which like in what we're trying to do today. So this is the architecture for this application. So we're reading from source, we're adding timestamp, and we are calculating trend. We're storing this trend and grouping by transaction. We store it in a map. We use this map to actually calculate and predict the fraud activities. And as you probably know, Hazelcast allow you to actually output to multiple things. So you can either store it in file or send it to Kafka topic or send it to web app or SQL browser. I will show you in our management center. So with that being said, let me just jump to my IDE. So feel free to leave any question you have about the architecture. Here, so I'm monitoring the chat at the same time. Right. So what I want from you is to look at essentially my POM file here. So we are quite excited today that we actually announced the 5.2 version. So if you haven't downloaded yet, you can actually download it today. And essentially, I'm just importing the Hazelcast to my application. And obviously I'm enabling digit or stream processing. And this is my application. So my application basically has 3 lines. First line is I'm trying to build a pipeline based on the probability score file, which I will show you in 1 second here. Let me check if I'm sharing the right screen. So it's essentially it's a CSV file which has a date and time, transaction number, and score. So this is my input. And if we jump back again to the IDE, what we're looking at is building the pipeline. So the pipeline here, as you can see, we're creating pipeline, and then we're creating a stream stage based on this score that's essentially coming from the CSV file. And what we were trying to do is to group after we read data into Hazelcast, we're trying to group it based on the score. So we're trying to identify trend, and this trend essentially is based on the score. So this, based on the transaction score. So this will allow us to create this trend, and we store it in map. And then we can jump to create the score probability. So this is where you can apply your machine learning model. And it doesn't matter much because after all, the model itself has some priority, but if you want to scale your application, you probably need to initiate multiple instances of Hazelcast. So feel free to change this code. So the code is available online, and it's on the Hazelcast demos on GitHub. I will share the link in a few minutes. And I look at the trend, and essentially I say if the score is greater than 100, give it a score of 1. So there is a possibility of creating a fraud. And if not, just put it to 0. So as you can see here, we have multiple options. So multiple options to send the output either to a map, for example, or you can send it to JSON, or even if you want to, you can send it to Socket to create a web application. Now, once I run this application, which what I did here, you can see essentially I used the Hazelcast, and I will be looking at this IP address and this port. So this is where Hazelcast runs. And I will use the management center and the SQL browser to look at the data. So my terminal, I use the management center. So you can use various ways to run management center. I'm using Docker in this case. So I'm defining the actual port and the version of this. And now after running the application, you can go to localhost, as you see here. So the SQL browser, which is part of the management center, so let me close it here. Right, so yes, and we're looking, so this is the management center here. So I can track my data. So you see I have 2 maps here. If I click on maps, I have the trend and I have prediction. And if I click on the SQL, so you see the transactions appear here. So I'm just selecting everything basically. And for example, for this example here, based on this model, you can see the first 5 transactions will be normal, and then the following 3 transactions might detect a fraud in here. Obviously, you can change the algorithm. So instead of using a linear regression, you can use any machine learning algorithm, or even you can combine between multiple machine learning models. Obviously, you can use Java to write your own code, or you can use the inference runner. So if you haven't watched the previous stream for the operationalizing machine learning, we had a demo for machine learning using Python code for online movie recommendation. And you can also check the code which is available online. So if you go to our GitHub repository here, so we have a couple of examples here. Obviously, you can have a look at the examples and the machine learning model. Essentially, you can also download it from here, which allows you to either change the code or run it locally on your machine. And while we're still here, you can also check our new announcement today. So the 5.2, which you can download from Maven now, as you can see here as well. So with that being said, let's just stop sharing screen and go just to summarize what we discussed today. So what we discussed today is kind of like how you can scale your real-time application. So especially in the machine learning area. So in machine learning, what we're looking is not the best model, which gives you the best accuracy. And instead, what we're looking is the composite between multiple algorithms. And this is what will give you best results, especially when it comes to deploying your model. And especially also if you want to scale it as well. So with Hazelcast, what you need is just to enable multiple instances. You can run your machine learning model within the Java code, as I showed you here today, or you can use our inference runner using the Python code, where you can write your machine learning model in Python as well. And let's just go back again, because I would like to discuss a few topics about our community through my presentation. If you have any question, leave it in the chat box. So our community is growing. So we would like to ask you to join our Slack channel. You can scan this code. Let's just move this from here to here. And we also do the weekly live streams on Twitch. We also have our technical blog posts as well, so you can check our community users' contributions. And we will soon relaunch the Hazelcast Heroes program. So with that being said, I would like to thank everyone for attending our live stream for today. Apologies for changing the schedule last minute, and we'll speak to you soon as well. Have a good day.